If your question's bad enough, we can just say, okay.
Yes.
Yes or okay.
yellow.
I don't know what to do. Yellow.
Or a student or a student walks in with a question. It's like, have you heard of Bert Russell?
Bert
Russell. No, but I mean, the first thing I do is I just go into full-on forensic mode, and I say to him, please show me your URS. I just want to see what we're working with here. Like, what shape is your baby?
What's your problem?
What is your problem?
And the best thing, what's your problem? Oh, I'm to design it. No, that's what your design is. What is the thing that you're solving?
No.
Is this toast coming today, or are we just going to sit here and starve?
I think this toast has started. This is what we call a cold start.
Fair enough. So welcome to Toasting Design number 5. I think it's close enough. Once again, you got me, Mr. Schekman, or Shaka Schekman. We've got Mr. Mark Boer once again, and then for the first time, we've got Dr. Randall Paton.
There's some style here this morning.
We can just call it Randall, it's fine.
We will get down to that, but let's be formal to start with at least.
Fair enough.
So today what we're basically tackling is questions and the way questions are asked. This is not necessarily even just questions to supervisors or to clients, but actually just questions that you might need to be asking yourself in order to get that information necessarily in the first place. How we know or how we've encountered it to be asked incorrectly or poorly or weakly, and then maybe how we might correct that question in such a way that we can then, or that you can then be better at design, in theory, anyway. I think. I'm not being interrupted, so I'm going to keep going.
I've actually just got quite a short example to run through. And part of the thing with sort of asking the right questions is about planning. And planning is, it's not making a list. It's things to do and then also how to achieve them.
Yeah.
So the example I've got is, I'll take Dr. Paton here, who's recently got a new car. In terms of a useless plan, is somebody that just goes and buys a new car.
Yeah, no testing, nothing.
In terms of a complex and ineffective plan, that is where the person who wants to buy the car would make an individual list of what they want. They would then ask their wife what they want. They would then ask the kids what they want. They would then make a list of all these wants. At that stage, fire up the computer machine. They would then use Google to start searching for things that meet this weird sort of list of wants. Obviously, they would search online. Anyone that is really, really bad at doing anything generally uses the internet first. They would then...
he can't read his own handwriting.
Refill the audio listeners.
Refill the current car with fuel for the road trip. Then go to 3 banks to find out what kind of loans and deals could be gotten. Then go home and evaluate. Then obviously chat to the wife. Then go and get the loan. Then go out for dinner to celebrate. Get more fuel on the way home. Order the car online and then buy the champagne. Where a clear and effective plan would be to make a list of wants, wait them out, start searching for something suitable that meets the when you need it and the budget, and then go and get the car. And generally, as soon as a student walks in and asks a question, it's abundantly clear, is any planning behind this? Is it going somewhere?
Yeah.
And that's basically sort of what we end up doing, is we just put up this sort of wall of questions. Like that question came in, and then we do this whole kind of process in our head of that question. Each word in it, there's stuff to try and understand behind it.
Exactly. Yeah. God, actually, it's kind of scary. Actually, that example there is pretty much exactly how the students actually undertake design.
Yeah.
You see, though, there's a part of me that disagrees somewhat with your example of something not being effective, because I am of the opinion that a comprehensive list of criteria is important for selecting a design.
Yes.
Because the example I always use is dating. If your list of criteria is must be human, then you have 7 billion people to choose from. But if your list is must be human, male, live in this area, have this kind of job, drive this kind of car, have this color eyes, this color hair, have this kind of build, whatever it is, be kind to puppies, then you can start to narrow it down and actually make a choice.
We're not saying that you don't have a list of criteria necessarily in that. It's your
But the process is too convoluted.
Yeah,
Yes.
the process and the way where you first look at, all right, I need someone that's human. So let me look at all the humans.
Yeah.
Then, okay, now I found all my humans. Let me look at all the males. Now let me look at and then you look through every single male.
So you're 100% right. It comes down to that kind of cascade of which one in what order to get your sorting range down.
But where I think your example was good about what is ineffective is you need to have input from all of your stakeholders. The problem is, in that example, you had minority stakeholders, literally,
Yes.
children. It doesn't really matter what your kids want out of your car. If they are toddlers, they will want a screen and I don't know what
A
else.
bubblegum flavored
But-
seatbelt to nibble on.
Whatever it is, their opinion should be weighted and possibly ignored at selection stage. You can modify afterwards. You need to be selective about the stakeholders that you actually interview or whose opinions you take on board when you are trying to pick a
So
design.
if we try and stay focused
Yes.
with the theme for today,
Agreed.
it was all about sort of how students ask questions, how they ask the wrong questions, or how we read the questions and then how we sort of respond. I know I suppose most people are guilty of this. The amount of effort that the student puts into the question is often balanced by how much effort I put into the response.
Agreed.
Sure.
If a student walks in there with, how do I do this, and presents me with an Excel spreadsheet, they get a free ride down the stairs.
Yeah,
Basically not interested.
yeah, exactly.
You know, debugging Excel is not what they came to ask, but that's what they came to ask.
Also, sometimes it's not even a question. The student comes to you and doesn't even ask a question. They just say, I don't know what to do. Now, that in and of itself is not bad. But if you haven't actually tried to come up with some ways to resolve your problem, and you just come to me and say, I don't know what to do, no question asked, no attempts to resolve your problem, there's nothing that I can necessarily do because you're not actually ready to solve your problem.
So
I
then-
could make suggestions, but you won't
So
be able to discriminate between
So
them.
what makes a good question? How do you ask a good question?
Okay, I think it's two parts. It's almost like in any kind of report, you got to give a bit of a background.
Yeah.
No, not I don't know what to do, but specifically what don't you know? Lay down the groundwork. This is, or even like your lit survey as such. This is what I've got, and with this, I'm not sure on step 2. I'm not sure on what is to follow. Best thing then thereafter is this is what I think I need to do.
Yes.
Because then you know what, fundamentally when I'm looking at a question, I'm trying to work out where is the student's base, where is their fault from. I'm not going to just tell you an answer. There's no point in just telling you the answer of, all right, now do this, because that's a waste. Because in that one situation, that one particular area, you now know what to do. But any other one,
I don't know what this is. Sorry.
It's a telephone.
No, but who is calling me from an 043 number at this time of the morning?
At 4:30 in the morning when we make these podcasts.
yeah.
This
Should
is
we-
the life of a lecturer.
Should we call out the exact number and then people can call and ask what they
Well, it didn't show up on my. No, I'm not going to. I'll let them leave a message.
It might be the
after.
dating service.
Yeah, that's not needed at the moment. Bay is on their way back from Europe. So you were saying
So,
about
anyway.
asking the questions.
So with that is it's a case of trying to work out where the student is then coming from. Where is their fault? Because if I can work out that, then I can immediately address the problem. Rather than giving you the answer to this one particular situation, which a further caveat and a bit of a sidetrack is when you hear one person give an answer to one student for a particular situation, doesn't mean it automatically applies to your situation in the slightest. So when asking your question, give your basis, give what you understand, so that then there's something to work off of. See, you're wrong in this particular area here. That's where you suddenly went sidetracked, or that's how you suddenly got confused. If you give nothing, I don't know what to do, as an example, then you're going to get nothing because there's nothing to work off of. It's the okay as an answer because fundamentally there's not much more else to say.
Well, this is actually, I use this analogy a lot. I call it the Chinese food problem, Chinese takeout problem. When you've got a group of friends and you've decided you're staying in and you're ordering some food and you ask people what they want, everybody just says, oh, I don't know. But the moment you say, okay, we're getting Chinese, then someone will say, no, I want pizza or I want, whatever it is.
Sure.
And because you've given them a point of reference, they can actually crystallize their thinking to figure out. And this works really well when you're doing stuff like group design, because you say to someone, I want to have spiked snow tires for driving in the desert. Probably not a great approach, but if nothing else, it moves the conversation forward, because the other people can say, well, that doesn't work because, and that gets them thinking on a solution. And the same thing when you're stuck in your own design. If you're working on your own, which design is very rarely a completely solo exercise, but when you're working on your own, if you find yourself stuck, just try something.
Yeah.
Sometimes you've got time pressure, which makes that difficult, but try something. And if it doesn't work, and you've tried a few things and they still don't work, go to someone and ask for help, because that's the other problem. A lot of guys don't ask questions in the first place.
Provided they have the right questions.
Yeah,
So,
sure, but they sit and work for 2 hours, 2 days, 2 weeks, and then they come to see you saying, I've spent 2 weeks trying to do this, and like build a MATLAB model.
Yeah.
And you say, but why? This is irrelevant to your design.
To me, every single student that walks in and asks any question, regardless of what it is, at the sort of early stages of design,
Great.
generally it involves, please take a seat.
Yeah.
And let's just go through what exactly are you trying to do here? And it's because they've reached the stage of they think they've defined the problem, which is what the URS is supposed to do. Clearly define exactly what is required.
Yeah.
And they've gone one step further, and then there's something that just doesn't sound right. It doesn't look right. The maths, the numbers are wrong. There's something funny there. And you have to literally go all the way back right to the start and ask them that decision.
Yeah.
Why? And why that one before this one? And you end up being over here.
Being able to answer that why is actually very important. I had a student mechanical design. They're much more subjective. But it's not impossible to apply design thinking to that kind of thing, which is why it was a design project. The problem was when the student came to see me about their design, very close to when they had to hand in, unfortunately, too close to make any course corrections, they had made a number of design decisions. And when I asked them, why did you make that decision? They said their only answer was because they thought that was right. They literally had nothing to back up their decision. They hadn't calculated a cost or whatever it was. It wasn't properly justified. And that, I think, is something else which leads to people ending up in the I don't know situation, because they've made a decision which is actually arbitrary. And arguably all of your design decisions are arbitrary, but they can't go back and track back their own thinking.
Yeah.
Because there's no paper trail. There's nothing to justify where they are.
Alternatively, they've got a reason, but they've now forgotten it.
Yeah, well, there's that as well. Keep a design log, guys.
Or
Keep a
something.
design
Make
log.
notes.
Something.
So in your opinion, I mean, I've always kept the design stuff in a kind of workbook, because you don't have the loose pages.
Yeah.
And Prit is your friend. You do something, you do a doodle, mark one CAD, print it out. This is what's wrong. This joint needs to move. Keep a record of it, because you have to finish design before you can report it. A lot of students come with a question of, I realized a mistake. I've written the report. Do I go back and mention how I fixed the mistake? And the bottom line is, theoretically, you should have finished it, debugged it, and when you write the report, who cares how many mistakes you made?
You don't talk about your mistakes.
Yeah.
It's not lying. It's not being untruthful. If you've made too many mistakes, you're not going to have enough actual material to actually show in your design. That'll clearly indicate you made a lot of mistakes. But you don't say, you don't have 10 pages of something to stop and say, you know what, everything here is wrong. Let's restart again. That you don't do that. You don't point out that, because then what at the very least you've done is you've set up, well, they're wrong first time, I'm going to guess they're wrong second time.
And it means the student has planned the whole project badly, and that they've done it while they're right, and it's too late to come back and fix something.
I think as well, even though, drawing on excuse me, my, separate experiences, computer programming, like it's a thing you do. None of us actually do it until we realize that we really should be doing it. But there's a thing in programming called a Git, which is a log of changes that you've made to the program that you're writing. So that every time you make a substantial change, you save a version and you log what changes you made, so that if the changes were bad, you can go back. And especially with things like CAD models, and if you're making a complex CAD model, save the old versions.
Yeah.
Hard drive space is cheap if it only has to be filled up for 8 weeks.
Yeah.
Don't go and irrevocably change the version that's on your Google Drive, because I can tell you now, it spawns everywhere and it's lost. You cannot, well, you kind of can, but because Google's decided to build that in for you, but it's not that easy to get to. If you can still keep track of what you've done, whether it's a paper log, a notepad file, an Excel spreadsheet, you've got basically the analog of a paper thing on your iPad or tablet or whatever, where you write it, handwrite it, type it, whatever. Keep a log of what you've done in some form, because 8 weeks doesn't sound like that long for a project if you think you're only doing one thing. A lot changes in 8 weeks. You go from no design to a design.
Or changing what the
changing the project
if
entirely.
If your problem's not properly defined, you could end up doing about 4 different design projects in that period of time.
Agreed.
So one question I get a lot, and it's back to, I guess, the question stuff. I have a student that comes to you with the idea of, all right, I've now calculated, my bolt stresses, I've calculated my weld analysis, I know the stresses in my beam, I have drawn up the manufacturing plans. Is that enough?
Yeah.
So, firstly, what's wrong? What would you say is wrong with that question?
My biggest argument is that question comes from people focusing on having to get marks. And yes, the university system is quantitative, and you do need to pass a project to be able to pass. But that's why we also have ELOs.
Yeah.
You have to be able to pass a skill assessment, which is completely subjective. But when somebody says, is that enough? My answer is, does the design work? Or actually, what I always say to students very flippantly is, how many roads must a man walk down? To quote a very, 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 very old song.
To me, the other thing is, the students that come in with, the questions about, I've done, an analysis on this and this and this and this and this. It always comes back to, why is it welded?
Yeah.
And if that is properly justified, absolutely marvelous.
Yeah.
If not, the weld might be just a stocking filler and pointless, in which case, if it is irrelevant to the design, it's almost not marked. In fact, it's a bad decision.
I think as well, what you're talking about, at least from the perspective of a supervisor, excuse me, is the context of the question. If we have been kept up to date with what you're doing in your design, we've met once a week, or you've dropped us a little mail just to say, this is what I'm doing this week, or however it is you're doing it, then when you come to us with a question saying, I've done this weld analysis, but 2 weeks ago you already told us why you've chosen a weld, then that's fine. We can say, good, you've done a weld analysis, you've showed us you can do it. But if you come to me 6 weeks into the design and say, I've done this, this, and this, and I'm like, why are you designing a donkey cart when I asked for a go-kart?
Yeah.
Then there's a problem.
Because the thing is, with this question, there is both the answer of yes and no that is perfectly applicable.
Yeah, absolutely.
Because is this enough? No, that's not enough. Because if your weld analysis is on one small bracket, it's a weld analysis. You have done a weld analysis. So when asking that question, we actually, in fact, most supervisors should never actually say yes. And if they do say yes, just do some more anyway, or get some more information, because unfortunately, that's not enough information to say that's enough or not. The answer should be.
And also, any form of analysis shouldn't actually take that much time.
No.
In fact, design is the collective, how all the stuff fits together. The fact that there are, bolt calculations and beams and free body diagrams, that's all wonderful. But the design part is, why are the forces in that direction laid onto that piece of geometry? That's the bit that has to be done in a lot of detail and explained in a great deal in a design report.
Yeah.
In an applied mechanics exam, who cares why the loads are on that beam in that direction? Can you drive a calculator?
Yeah.
And I assume if you're in your third year, you've passed applied make A and applied make B, and you've passed second year maths, you can do that stuff. You don't need to show me again that you can use every single one of those calculations and stuff. Or you don't need to come to me and say you can do that analysis. I hope you can do the analysis. If not, there are bigger problems. It's more, how have you used that analysis? How have you used that tool or that methodology to solve a problem? That's how your question should be orientated. What is this? Instead of saying, this is what I've got, tell me what the state of your design is. I've got a design that is this big, and I know this, and I know this, and I know this. Not what analysis you've done, because the analysis is a stepping stone between nothing and a something.
Well, I mean, there's 2 points for me about that. The one is, supervisors are people too, and if you say to us, is that enough? Sometimes we don't have that much time and we're going to say, well, probably in our head.
Yeah.
And we might say, well, probably to you.
Sure.
And if you push us, we'll say yes or no. And you've got to figure it out, because in life there sometimes just aren't these answers.
Yeah.
But secondly, to extend your example of the bolt analysis, and that you should be able to do it. If you present me with 2 pages of bolt analysis in 4th year, when all you're going to do is pick a bolt out of a catalog, then all you're doing is you're trying to dazzle me with equations. But actually, I'm like, your time is too important by that point to be doing bolt calculations. You should be able to say, I need at minimum this size.
Yeah.
Move on.
Yeah.
Because I want to get from the beginning of the design to the end. I don't need you to spend however many hours writing up bolt calculations.
Yeah.
And so when you come to me with a question like, I've done this analysis, is it enough? I'm like, is it enough for you to be sure that your design's going to work? Okay, move on.
Yeah.
And then we all have the greatest question in the world, is when you take any question a student asks and it gets posed to you the day before the design project is due. Because just as we are human beings, students, believe it or not, are human beings as well. Letting a student down with oh my goodness, you're in so much trouble, this thing is terrible. Your analysis is okay, is generally, the do your best, wrap this thing up and submit it.
Well, there was the notorious case of the guy who, 5 days before his design was due, couldn't understand why his blimp was so big, and it turns out he had forgotten gravity in all of his calculations. Everything had to be 10 times bigger or 10 times smaller. I can't remember what it was. It was ridiculous.
And in terms of an answer for that, you're not going to get an answer that's helpful to you, because actually that helpful answer is more detrimental to you than anything else, given that you have no time left.
Something you should understand about when we answer these questions is we are also trying to manage your stress levels, because we don't want you to burst into flames.
Well, in theory anyway, yeah.
Sure.
Okay, so that's a good wrap up then.